Yeah, hello. Hello. Hope I'm audible. Saurabh sir, can you please confirm once?
Yes, sir.
Yes,
Yeah.
sir. Yes, sir.
Thanks for the confirmation.
Malika madam, are you there?
Yes, sir, I'm there. Hello.
Yeah. So Malika madam, we can
Hello.
start the meeting. As of now, I think our guest speaker is also there. Our honorable director sir is also there. So we can start. Saurabh Sharma sir, can we start? Okay, we can start, Malika madam.
Okay, sir. Good evening to one and all present here. I, Professor Malika Roy from CSE Department of Bradaria Global Institute of Engineering and Management, Jabalpur. On behalf of our institution, I welcome to all present here for the FDP on data analytics with IBM Cognos. The objective of this 7 days FDP is to unlock the concept of data analytics and to understand the fundamentals of business intelligence, including data integration, processing, and presentation. Gain proficiency using Cognos for data visualization and analysis. Learn how to clean and prepare the data with Cognos. Explore the architecture of Cognos and understand its interface, field types, and data source management. Develop skills creating various types of visualizations and charts with using Cognos. Learn advanced techniques such as data blending, data manipulation, filtering, and creating interactive dashboards and stories using Cognos. Now, I would like to invite our respected director, Dr. Rajiv Khatri sir, to kindly address the FDP. Sir,
A very good evening to all of you. Mr. P. Mohan from Tech Mahindra, the keynote speaker and resource person, officials and participants from Smart Bridge interns, my colleague, HODs, faculty members, and dear students. I welcome you all to this FDP. It gives me immense pleasure to note that Department of Computer Science and Engineering, Baradia Global Institute of Engineering Management, is organizing this 7 days FDP for the PG students and faculty members of our region, along with the Smart Bridge interns on data analytics with IBM Cognos. IBM Cognos has wide scope in the industry today. With the boom of data, Cognos is widely used by business analysts, data analysts, and data scientists to deal with data. Most companies today ask for proficiency in at least one of the business intelligence tools, and learning Cognos will provide with an advantage if one wants to start his or her career in analytics. This FDP is in line with train the trainer concepts so that our faculty members will get enlightened with the latest knowledge in the field, and by which they can further disseminate this knowledge to our students. I hope the participants will take the best advantage of the vast knowledge and experience of Mr. P. Mohan. I appreciate the efforts of HOD, CSE, and IT, Professor Saurabh Sharma and Professor Vishal Paranjpe, for organizing this FDP, and hope similar FDPs will also be organized in future. I extend my best wishes for the grand success of this FDP. Thank you. Jai Hind.
thank you, sir, for addressing the occasion with your valuable thoughts. Now, I would like to introduce to our resource person, Mr. P. Mohan, sir. Sir has done his post-graduation in computer science from Osmania University with an experience of over 23 years, including industry, corporate consulting, and academic research. He is currently working as Senior Data Scientist at Tech Mahindra, Hyderabad. He has published various research papers in reputed national and international journals across diverse verticals like information technology, marketing research, software testing, banking, and finance, etc. He has trained several public, private, and government sector like NTPC, NMDC, ONGC, DRDO, BHAL, and many more. He is the advisor in area of data science and artificial intelligence from Information Technology Division at SmartBridge Educational Services, Engineering Staff College of India, Hyderabad, and is a member board of studies for Department of Computer Science Engineering at G. Narayana Institute of Technology and Science, and Bokaraju Rangaraju Institute of Engineering and Technology, Hyderabad. He is also the Board of Studies member of Department of IT, BVR IT College for Women's, Hyderabad. He is the knowledge resource of chief mentor for National Institute of Smart Government in the area of data science, machine learning, AI, and fintech and technology tourism. He is a visiting professor in management for ESCI School of Postgraduate Studies, Hyderabad, VIT University, Chennai, and SRM University, Chennai, and MNR Medical College, Hyderabad. He has also trained several aspiring research scholar, faculty member, and student from American University of Sharjah and the University of Sydney, Australia. Now I request Sir to start the session. Over to you, Sir.
Yeah, thank you, Madam. Very good evening, one and all. Am I audible to all of you clearly?
Yes, sir.
Yeah.
Yes, sir.
So, wonderful evening to all our esteemed faculty fraternity from academia, Mother Area Global Institute of Engineering and Management. Thanks to Team SmartBridge for organizing this wonderful program. Would officially now start the proceedings on this journey on the faculty development program on data analytics with IBM Cognos. I'll share my presentation here.
Yes, sure. I'll stop sharing my screen. You can.
Yeah.
So now you have an access.
Please confirm, Shivam, can you see the presentation? PPT is visible for all the...
Yeah, it's now visible, sir. Yeah.
Thank you. All participants are kindly requested to go through the technical presentation session for day one. I am live on my Zoom chat window for any queries or assistance or communication. I request all the participants to keep their microphone mute during the session. For any queries, you can type your query in the chat. We also have a dedicated Q&A session at the end of this online virtual training session. So without further ado, welcome everybody for this evening on the virtual training program on data analytics with IBM Cognos. The agenda for the day one session on this evening goes like this. We'll start with first understanding the current business scenario in the global terms. Under this chapter, we would be addressing about why decision making in business world is becoming so challenging and complex in different type of industry verticals. Currently, what are the typical challenges that are prevailing in the industry verticals? Where is the actual information gap? How should businesses, industries should prepare their roadmap ahead of them to face the stiff competition and move towards operational excellence and organizational excellence? Then we would look into the core of our discussion, that is the business intelligence paradigm under the umbrella of data analytics. We'll have an in-depth understanding of, with an overview of BI, what is BI, why BI is actually required in the present day scenario and how it evoluted and how it got transformed, right from the evolution to its technical mechanics, that is the framework of business intelligence, starting from data integration from a multitude of data sources. And also we will throw light on this session, on what are the different tools, practices, and methods usually that organizations that are implementing BI would actually follow. In this regard, we would like to explore the most important prominent architecture of BI, that is ETL, extract, transform, and load process. Then we will move towards data analytics, which actually is the theme line of the faculty development program for all of us, will understand why the changes or the transformation from BI to data analytics took over in the time. We'll take a quick overview of why and what of data analytics. We'll also leap into different types of analytics categories and with some application use cases. To also align our objective of learning the practices much more practical behind a theoretical approach. In this session, I would like to emphasize on the importance of data visualization, the need of data visualization in real world business intelligence framework. And we also look into the best practices, how a practitioner, researcher, or a data enthusiast would align their learning curve, beginning from what kind of visual practices has to be understood initially. The session then concludes with Q&A by the participant. So this is the workflow of the evening session. So let's start with our basics. Now, if you see the problem of data explosion, actually, the world is severely undergoing a lot of transformation changes from the millenniums and decades. Globally, if you consider business segments, business verticals can be ranging from varieties like spanning from healthcare, banking, manufacturing, pharmacy, pharmaceuticals, retail, real estate, e-commerce, whatever is the value chain in the business. Commonly, all these evolving business verticals are seriously suffering from one of the global problem, that is continuous rise in data. Business processes are the actual sources of data generation in the real world. While people compile and define the business processes, each business process is defined by a set of valid inputs and expected outputs. During the value chain of this input to output process system, there generates the most pivotal element or the driving force of the business that has to be unrevealed, unlocked to generate a value out of it. That critical element of the organization or the asset, typically, if you would like to define it, is what we call the data. Historical observations clearly tell us a fact that from a decade at least, the time that we are in currently, at least if we look back a decade of years from the current scenario, global world witnessed a tremendous exponential rise of data in terms of volume, in terms of variety, and a velocity, that is massive speed with which the data are being continuously generated from various sources. Typically, the sources of data usually include the corporate business processes and powered by the technologies like internet and social media, and also the current generation of our industry, that is the 5th generation of our industry, where a lot of data are automatically generated by micro to macro sensor devices. Like dawn of time to the evolution of technology, where technological growth is phenomenal and revolutionary. Interestingly, the growth of data parallelly is also very challenging for the businesses. Now, organizations should understand the value of information technology practices on one side and also data-driven practices on other side, and try to understand the congruence and alliance of these two and keep pace with those alliance, and then move towards a new methodological paradigm called data-driven transformation or data-driven decision-making practices. Now, why businesses actually need some empowerment or rich support for one of the most critical factors or KPIs, that is decision-making. What makes businesses move towards transformative architectures with IT? How could they add value to businesses? We all know that we are living in a very stiff and competitive world where the dynamics of the business process, the expectations and requirements of the end user or customer in the market are evolving and dynamically changing. How can businesses actually prepare for the today and tomorrow, or the present and future? Is there any learning that the organizations could actually look into from their past, try to explore the knowledge insights from the past and actively put them into action so that they can move towards wiser, effective and efficient decisions for the prosperity of the organization? So this is one important reason why the businesses, irrespective of the type and size or complexity, are now trying to look forward for alternatives. The global competition is nonetheless an exception. We all need to go through this, irrespective of the fields that we work for or organizations survive or strive to. The customer in the market, who actually is the one of the primary reason for the transformation, business transformation, irrespective of the product and service that organizations offer to the market customer, the timely changing or dynamically varying expectations of customer is one of the critical driving forces that would challenge the quality, accuracy of decision making for a business, be it in terms of pricing the product, quality of service, or other business constraints. Another important thing is, with rapid growth of information availability, publicly available on online platforms, technological resources, it becomes now imperative for companies to venture into those information availability, information sharing resources to have a striking edge or a feature towards success. All these would be discussed in terms of industry challenges in three important areas. How could organizations, businesses, enterprises need to prepare the roadmap from the current to the better future? There are three key industry challenges for information. One is, every organization usually generate data from their business processes, which can be considered as the primary source of data generation. Alternatively, the second source is like interaction with stakeholders like customer, supplier, vendor, or any other market entity that would also add value by attributing to the data. Apart from these internal, external sources or primary and secondary, there is a third category or tertiary source of data generation, which is through the robust information technology. Be it a telecommunication, or be it a groundbreaking internet technology, or be it the phenomenal social media of today, all these entities of the IT are becoming very desperate or phenomenal sources of data generation in enormous quantity and quality, trying to challenge the operational performance of the organizations. Thus, our efforts to focus on why and what of business intelligence basically starts with understanding the availability of data or the generation of data from diverse or different sources in the universe. That's why the first challenge, why organizations who are trying to learn, understand, and implement the modern IT practices like BI, that is business intelligence, or business analytics and data analytics, the nomenclature, it all starts with understanding the available sources or range of data that are being generated from. Typically, based on the nature of business, data might generate from the multitude of variety of sources. Like some organizations might preserve their data in a file system, while most of the organizations would like to go for a very structured relational database management system, while others who have to deal with a mammoth of data every day might go for more sophisticated, scalable, and more highly secure virtual storage systems, even on the cloud servers. Whatever is the mechanism of data storage, the essentials would lie at the capability and maturity of those organizations in handling challenges related to data storage, as well as opportunities that lie with data processing, reporting, and knowledge management. Thus, data becomes the most crucial point in understanding the core of the business processes, extracting useful knowledge insights when properly explored, examined, or investigated, thus leading to quite handy, useful, valid information, knowledge reports, when synthesized properly, that would lead to better informed decision making by the organizations. The second industry challenge, which is from the technical point of view, that most organizations, before taking a plunge into implementation of an application IT infrastructure, is how they can handle the multiple sources of data volumes, because data comes from different sources and different formats. How the conglomeration of data should take place, how we have to prepare for having a holistic view of the data from a heterogeneous sources. That's why the second challenge is preparation of the data, or making data ready, suitable for analysis, reporting and interpretation, is the second best bet currently for globally for multiple industries. A lot of time in the IT industry or the application industries are spending their valuable time of the development process in R&D, and 80% of the project time is being spent only on understanding the critical nature of the data, or the essential prerequisites of pre-processing, that is translating or transforming the data into a format suitable for analysis. Because raw data, as we know, is voluminous, is not that tidy, and has less meaning associated. That's why a suitable, a well-defined and disciplined system in place should make the data go through the data cleansing or data cleaning processes need to be applied if proper benefits have to be reaped out or unlocked from analytical applications. Data analytics is actually two different words. Like data, the pivotal element that comes for the originates from the business process. Analytics is a bunch of experiments carried out by the observer or the data enthusiast or researcher in order to unlock the potential value of the data. While the third one is the environment. Actually, what makes the organizations need to look into in time of cost investments, especially to scale or gear up themselves towards utilization of the advanced IT. So there are many kind of IT practices, like from a monolithic IT, where we used to live in the conventional file systems in the early era, to the transformative cloud and other modern emerging technologies that we have timely evolved into. The third industry challenge is investing the efforts in terms of resources like cost, time, and manpower in building up a suitable environment that is capable to handle the data challenges. Especially speaking in terms of hardware and software, that is the cost and the efforts of processing the data, storing and managing the data are also a typical challenge that organizations actually have been suffering way back from. Is there any other kind of mechanism that could address all these three challenges, where we could get some kind of a trustable, reliable environment that could handle all these three important industry challenges in a single homogeneous platform? The answer to this question, or a global $1 million question, is we need to create a homogeneous unified data analysis platform. Let there be multiple sources of data in real practice, but all just try to become homogeneous at a single stage, where we could do some kind of data management practices and then try to take it forward for further analysis and reporting. With that vision in place, that and to also to address the capability of the maturity of the organizations in understanding the value proposition behind the data, how raw data can be transformed into a format that finally, as you can consider it as a processed information or a knowledge report synthesized properly. How can these can be useful or aid in the organizational decision-making process? That's why there is no deficiency in data, but there is lack of efficiency in processing the data. This is what most of the world actually witnessed. But now, with modern emerging IT practices, this gap is now slowly being resolved. That's why I quote, there is no shortage of data sources in the world, because businesses and from the variety of business processes undoubtedly the volumes and varieties of data keep rising and floating. But is there any proper mechanism in place or any architecture, framework or paradigm in place that could handle this kind of continuously evolving, exponentially rising data? So the answer here is now all organizations are looking into grasp or generate the intelligence from the data of the business processes itself by following a very systematic approach of transforming the data into very useful format for a variety of benefits for the organization. That is how the phenomenon or the concept of business intelligence arose in the real world practice. So if the major goal of BI actually is to establish a platform or bridge the information gap, which essentially information is crucial for effective and efficient decision making. Now, if you look at the industrial scenario in real world data culture, be it in academia or be it in industry, any kind of industry, one of the most important fact that we all need to look into is every one of us, by and large, will use some software at our organization. Like at your institute, most of you faculty might use different kind of learning practices for your research, for teaching, learning pedagogies with your students in the environment. Essentially, industries like IT, pharma, bank, all these will try to use the required software for their day-to-day business activities and data processing. Thus, there is IT everywhere across the world. But taking it going forward, if you agree the fact, if 80% of the world is knowing what to use, when to use, and how to use which IT, a typical raw fact is how many of these within the organization or global around the world would actually have the access or the enrichment, empowerment towards looking into analytical insights. Only 25% of the workers in an organization at a capacity have been observed to found that they could have, behind using the application IT or application software, would take a further step forward to look into the analytical insights, which usually are hidden inside the deep, very deep inside the depth of the data. That's why our efforts in this FDP is to empower all the participants on the importance and the need of the hour of discussion on, besides using our IT practices in our day-to-day routines, can we go further a step ahead and really discover the art and science of looking behind the data of the business processes through analytical approach and research methods. So if given a chance, if each and every one of you could try to look into this opportunity in the 7-day journey and make ourselves armed with the necessary knowledge, and then further empower others in the world with analytical practices wherein the decision-making processes of the business would further be no longer a challenge after the outcome. Now, if you see how the IT is applicable in the real world, there are different practitioners and users related to IT in different spaces. As a end user, we use different IT-related services and IT-related products, be it a search engine, a social media platform, or a mail activity, or any information messenger tools. Typical in an organization also, these kind of categorization of the user right from the nature and type of IT usage can be classified. How IT is useful to a data analyst in an organization, how IT should be really useful to an end user who might be visiting a website or a mobile application, how IT should be useful to a layman who doesn't even have much knowledge about this thing. The spectrum, the complete spectrum of IT application usage, right from design to development, to put into implementation, business process management, and then thereafter routing to data management practices, is a complete vision of the business intelligence paradigm actually. Now, after initial talk on BI, like it would be our point of discussion, what BI actually can do in the real world for us. Essentially, business intelligence or BI shortly is defined as the science of looking into the volumes of data that were generated or collected in the real world and try to do some sophisticated processing through some scientific analytical approaches. So that is the core of BI and its major. But we already looked into past few minutes that variety of information sources are definitely there in the world. Besides the internal data sources, that is the business process and the people, external data sources, that is other entities like business stakeholders. How could we manage all these plethora of data sources, and how can we look forward for a commonness, a holistic approach? What methods need to be understood for bringing all them on a single platform of the integration techniques is where BI actually starts its workflow. After we achieve a homogeneity from the heterogeneous data sources, the next opportunity for us is to perform the rigor analysis, turn data into most useful, valid, reliable information through different practices that are now in place, like pictorial representation of information via charts or graphs, or more dynamic interactive dashboards, etc. Now, all these are aimed towards one common goal, like how can these data turn into stunning visual practices or BI practices can aid in better business decision making. Now, if you look at the journey of data translated into knowledge insights, there are essentially three layers of the BI framework. One is the capturing stage, one is the data processing, and third one is deriving the rich, valuable data patterns, typically called the insights from the data. But to begin with, data capturing, which is the preliminary phase of business intelligence framework, there are three varieties or categories of data that are generated or present in the real world. A structured data, which is the most fundamental type and found most typically in most business processes. Like if you consider the transactions that usually takes place on an e-commerce website or typically at a POS, point of sale store, at a retail grocery store, and a banking system or another kind of this thing, the range of data that get generated might fit into one of these three categories. Like it can be well-defined, structured, like in a relational, much relational way, calling it as a structured data system. Or it can also be more challenging with no proper shape and dimension, like data can go unstructured, like if you see a typical image or a PDF file or a Word document, where there is essentially not a typical or a regular pattern that would otherwise exist in the data. Between these two, there also lies the semi-structured data. Typically, examples might include an XML file or a JSON data format, like a web interchange JSON format, that would all fit into the semi-structured. Whatever is the nature of the data that is being generated based on the outcome of the business process, that shall be taken forward to the processing layer. In processing, one important challenge is how can we accommodate all these varieties of data on a single storage? Because we know structured data can be stored and processed and queried using relational data practices using a DBMS. But how to manage the unstructured, semi-structured data? One should understand the basics of the storage mechanics and processing techniques on the other categories. The world has lived with legacy practices of structured file systems, structured databases. Now with the challenges that are coming up and the nature dynamics of the environment, data takes a different shape and takes the driver's seat. That's why the transformation towards unstructured data volumes, semi-structured data varieties really challenged the heights of information technology practices also in terms of both storage and process enrichment. While BI exactly is born to answer the question at layer 2, that is processing, it also adds value by doing analytics on top of BI with data through rich visual analysis and exploration. That is where the synthesized data, structured, well-defined data are then taken forward in the next layer for reporting, analysis, and insight generation and management. Now, this is structured, unstructured, and semi-structured data are actually the outcomes of the business processes that are taken forward for processing, and later they are taken for analytical explorations and other experiments. Now, if you try to map out the evolution of BI over a period of time, how the BI actually emerged in right from the decades, if you see at least 2 to 3 decades ago, where the introduction of file systems and early database systems were during innovation phase, and to the current era, the 21st century, there are a lot of changes that took place in the data management practices. Keeping in view of entire operational organizational excellence, the proposed BI or the formulated business intelligence framework actually have focused on many entities, evolution of many entities. The transition of data processing systems from a simple 2-tier client server to a 3-tier web architecture and more robust SOA, that is service oriented architectures, and today more user friendly, manageable and scalable, secure, highly secure mobile and cloud platforms. This is the growth of IT over the dawn of the time. How should the business intelligence systems prepare their roadmap accordingly to inline with the evolving IT? Thus, at each phase of the growth of IT, you can clearly see the vendors, the IT market vendors who try to discover the opportunities of offering much innovative software for business clients, learners, researchers have been presented here. The BI tools essentially compose of the phenomenal data warehousing. Of course, I'll comment more on data warehousing architecture in the coming slides. From data warehousing phenomenon, that is the scientific way of conglomerating multitude sources of data into a single centralized repository to provide a holistic, homogeneous view for the organizational layers, be it strategic level, be it a tactical or operational level of organization. All players within the organization should have the capability and a suitable platform to access the data to generate insights from it. That's the essence of data warehousing actually. And to the business intelligence phenomenon, that is the art of applying analytical activity, analytical techniques around the data by using the data directly in order to generate the rich insights that otherwise would try to empower the organization towards optimization, sustainability, and growth. And all these would definitely give rise to a new turmoil or new transformation wave, typically the analytics behind the data. Thus, it is very clear from the illustration that analytics, when properly applied on the data, when data are drilled down, examined, investigated, explored, would now become a driving force for business process management. At the outset, this is how initially the BI evolution actually started with. I hope all participants are able to hear me clearly. If anybody has any audio issue, you can please report and chat to me. Yeah. Yes, let's proceed to the technical architecture. Yeah, thank you, Azeva, of BI. Well, most of your experience from your academia, teaching pedagogy practices with your rich research exposure already have certain insights with you. Let me take the opportunity to present to all our esteemed participants in this session on day one the actual reality that takes place in a legacy operational IT environment. You can see on the picture the usage of traditional data sources, like it can be a simple file system, like organizations record, manage their data in Excel files or some other formats that they normally, spreadsheet applications or flat files, text files, anything, CSV, anything. From such a legacy file system management, the world slowly transformed into usage of more scalable, robust architectures like a CRM system, customer relationship management, ERP, enterprise resource planning, an MIS system, management information, and other operational systems. That's why The journey of business intelligence starts with understanding typically what are the data sources in an organization which are available, be it a CRM, be it an ERP, or be it an operational system, or be it a very basic flat file. Organizations maintain all these information assets or data assets with them. Now our goal is, can we take some step forward to discover the opportunity with this FDP to put forward the technical framework that can integrate all the multitude of these data sources, which are heterogeneous actually in nature, and try to bring out them into a single homogeneous view that otherwise would be providing like a mirror image of the business processes in large scalable method for all layers of the organization. One such most proven practice in the business intelligence paradigm is what we call the process of ETL. ETL stands for extract, transform, and load. This is ETL. It's a three-stage layer process. I'll comment on what actually the purpose of ETL is. ETL, as you saw in the architecture, was basically focusing on combining data from multiple sources, because it becomes very challenging as organizations move towards their future, trying to revamp or re-engineer their existing IT practices by virtue of time. That would become challenging in times of cost investment, in terms of managing the data or information asset. That's why there should be some approach with which, with minimal effort and minimal investment, we need to manage our ever exponentially rising data. That's why the idea of central repository, where we combine, cleanse or clean, refine our data and bring forward into a central single view of the entire enterprise, is what typically the concept of data warehouse emerged in. Now, how that ETL actually works behind, what phenomenal processes go is, there are a set of business rules that are defined, a systematic approach to acquire, procure data from different sources, cleanse it, and then bring into structured organized format suitable for analytics. If you go back, the ETL then aims for building a very robust expanding data warehouse that is actually the enriched, cleansed, pre-processed data from various sources. And data warehouse now becomes the backbone for conducting analytics on these rich, ever exponential rising data. Analytical experiments or analytical experts try to form data warehouse as the basis and try to do exploration of data, visual analysis, and try to build robust reports and other analytical assets that like to do, and then try to rely upon decision-making practices for their future. Allied with the data warehouse, there is another scientific methodology that received more prominence in this architecture of business intelligence called data mining. As the name says, it is the art of trying to discover the inside out of data by using some scientific methods, statistical techniques, and other mathematical modeling processes, usage of computer algorithms also, all put together in a single place in order to reap out the benefits of the data that resides on the warehouse. How should organizations who try to venture into this BI framework, how can they make out benefits from BI? That is utilization of business intelligence. Essentially, BI systems, when properly understood and implemented, what benefits they can provide to an organization? First is, organizations will learn to know how to structure and maintain their data, which is a very typical element actually to deal with. Second, what to be learned, unlocked from the data, the value that really lies inside of it. What are the practices and what kind of methods that they need to look into in order to optimize the business processing time and maximize the business performance or growth, is where BI majorly focuses on. Second, bring out a sustainable IT infrastructure approach by streamlining the existing legacy IT infrastructure, by putting all the variety of data sources into a single homogeneous view. That is streamline the current IT operations which are in place. So thus, BI cannot be understood simply as a refinement or re-engineering in IT, but rather the higher vision, longer vision of BI in organization is, while one side the re-engineering of IT, the other side is leveraging on that re-engineered IT to move towards operational efficiency. If one wants to contribute to organizational productivity in any environment that we work for, definitely the processes and practices of BI could add great value. BI, that's why, is focusing on the capability to translate data into rich research reports through proper, robust data analysis and trying to aid in decision making. How and where we should start our journey in BI tools? Well, there are a lot of market tools in terms of software usage I'm talking, but the techniques and practices, the framework of the methodology of techniques and practices that one should understand as beginner must first be looked into. Undoubtedly, to deal with massive volumes of data that are streamingly or seamlessly generated from the real world practices from different sources and then dumped into the warehouse, the process is infinite and continuously going on. How do we handle that streaming data in place? A very worth notable effort by any data analyst or practitioner research data is start our journey with simple processes of visualizing the complex data. Because picture is worth than 1,000 words, it is good to start with visual practices, visual analysis or visual analytics in place. Then try to discover how we could model our data warehouse, that is single homogeneous repository centralized, and how we further need to look into subdividing the warehouse into smaller subsets of data, what we typically call data marts. That is, the ever-growing scalable data warehouse, timely updates, can be broken down in required parts onto view so that each end user might have their own view of data as and when required for leveraging value out of it. Data mining is the actual scientific methodology that shakes hand with data warehousing in order to add more value to it. All these are aimed at generating high rich knowledge synthesized business reports that would add value to the decision making process. In real time, there are two paradigms in business intelligence to be understood essentially. One is the OLTP, that is online transaction processing. The other one is OLAP, online analytical processing. I would present the operational view of OLTP in the next slide. OLTP, what actually OLTP role, where it fits into the architecture would be presented. Consider any business operation. OLTP essentially focuses on controlling, administering, or managing the day-to-day transactions. For example, banks who provide the ATM service for their customer for withdrawal, deposit, and other basic services, or any business vendor who is operating in the spaces of e-commerce, or any other transactions related to online banking or insurance. All these kind of information technology powered practices fit into the category of transaction processing routines. So if you see, the essence of OLTP system entities in place in BI is to keep track of the timely data processing. The major goal of OLTP systems in place are to keep track of data processing, but they don't venture into the analysis part of the data. That's why the volume and variety of data that OLTP systems generate by time is rising greatly. OLAP is a value added practice in BI, as the name says, analytical processing, where in the data warehouse, after the establishment of the data warehouse to systematic refinement, integration of data, now it's time to discover valuable insights, information, knowledge insights. That's why the goal of OLAP service in the BI architecture is to conduct data analysis on top of OLTP system, OLTP component, but it's nowhere related to data processing. So you can quickly sum it up as OLTP for data processing, OLAP for data analysis. That's why these two become the imperative elements in the BI architecture. So presenting to you the BI framework and data warehousing system setup in an organization. There are essentially different layers in setting up a good logical data model that would generate the business intelligence for organization. The very first layer in the implementation, as you can see participants here, that is the data sources layer. Recall the previous slides where we were focusing on the first component in the BI, that is procuring data from different sources. Data sources can be many and any. Typically, the database systems, which most organizations are reliable to store data on DBs or files. From these data source, a very important fundamental step is performing integration in order to bring forward the data into a centralized view. For that to happen, we apply the technical activity called ETL, that is extract, transform, that is convert the data into format suitable for analytical modeling or analytical processing, and then load the data into warehouse. The next stage in our BI framework is the staging layer. While staging layer can be thought something like an equivalent database that is much scalable and robust, or the other words, we can call this DB, staging DB, which is different from the regular DB in data source layer, as an ODS, that is operational data store. See, for instance, a grocery store or a retail supermarket that is operating conventionally at a geography might set up some kind of an information system in the backend to record day-to-day customer business transactions. So such an information system, MIS, can also be an ODS, operational data store, that keeps track of minute-to-minute transaction processing at the POS terminal. Again, from the staging DB, ETL is a continuous process until all the data are refined and translated into a centralized view. Thus, after accumulation of data, pre-processing and refinement from the ODS, that is operational data store, which actually is real-time data generated in a continuous stream, such data are then moved forwarded to the data warehouse, which becomes the foundation layer for analytical experiments or data analytics. Although legacy practices like we can still query our data from a DBMS also. A raw DBMS which contains amplitude of data can still put forward for querying. But a question of concern here is why these legacy practices are turning into more advanced practices of data warehousing. You can still write your relational queries on your data, right? You need not combine all the data from different environments into warehouse. Essentially, you can still do that. But why we are doing this practice, why the world is advancing to this practice, is the capability maturity of organizations to contain, process, and manage data with low cost IT investments and smart knowledge insight generation is the greater vision of business intelligence. That's why the paradigm shift, I call this as, is now the need of the hour. I hope everybody is able to understand the essentials behind of business intelligence architecture before we do a handful of rigor of experiments in the coming days with IBM Cognos. Now, the data warehouse tools are then focused on the access layer. Once data resides on the warehouse, now time comes for the people to look into the richness of the data, unlock the value out of data. But as data warehouse is now a single centralized view, you can imagine the volume of the data that goes in, the big data that could generate on the warehouse. That's why, based on the time and need requirement, data warehouse can be broken down or can be categorized or then further drilled down into smaller segments, what typically we call the data mart, or in our multidimensional OLAP modeling, we call this as data cubes. Actually, one can imagine data as a mathematical cube, which gives us opportunity to look into explore the data from multiple dimensions. On this data mart cubes, we could deploy the data mining practices, that is the scientific computing of the data through all the essential methods of stat, math, and computer programming and other visual aids, and then drill down what we require is the insights. Thus, the final layer is where BI tools come into play. That is, all the explored, visualized, modeled data then presented in rich report format to different layers of the organization, that is the strategic level or executives, the operational and the management level. This is how the implementation of BI system in real world could actually be conceived or understood. Any queries so far, participants? Please let me know. Hope all of you are able to understand the essence of BI systems, the setup architecture, how the transformation from a legacy systems to the modern IT practice is being presented. For if any queries, please ping me in chat. Now, putting this in real-time practice, like now we understood some part of why and what of BI. If BI is really implemented in an organization, I would consider a small-scale business as a use case representation here. Imagine a business is running in 3 different branches, running various branches across different geography. To drive the business effectively, there are some web interfaces or web media are being used, that is websites are being set up. This is totally completely web driven world nowadays. So the business operations, the visitor trafficking, customer management all takes place, imagine, with web pages. Each branch that maintains a front-end operational web page also has a dedicated DB, database backbone. Okay, so if you can see here, branch 1 maintains its web page or the interaction, entire business processing system takes place web interaction, has a dedicated database of day-to-day transactions. Similarly, branch 2 maintains its web page with a dedicated DB. Same is the case with branch 3, its web interface and dedicated DB. Now, if this business wants to know what actually is the performance of different branches, comparative analysis they want to carry out, is it required for the organization to individually explore each database at individual level, or would you recommend a combination of all transaction individual DBs into a single centralized warehouse? What would be the optimal solution for this business? Participant, this question is for all of you. Try to understand the essence of the question. The business is managing different branches. Operations are handled using websites with dedicated database backbones. Is it required for the business to manage the business operations by individually looking into each of the web operations and dedicated DBs, or there might be in future this business might look forward of integrating these databases because growing volumes of data might become challenging for querying the data or report management decision making? Is this organization might look into the opportunity of generating business intelligence with so-called what we discussed data warehouse? Do you believe in this? What do you say? You can reply with yes or no in the chat. Does this simple business might look into the opportunity of moving towards BI transformation? Yes, correct. There is a definite need to transform this business. If we talk about scalability, operational excellence, even such a simple business should move towards data warehouse. Correct. You're all right. Thank you. Now, after transforming this DB based business or a simple legacy business, IT business into more robust scalable BI, how the operational BI takes place is, while definitely unavoidably there are databases in the backend that take care of the online transaction processing. But when transformed into the online analytical processing, you can imagine now the IT component is scaling from files, data source systems, ETL processes, and then having dedicated databases at each layer, and then finally having a homogeneous huge mammoth warehouse within the organization on which we conduct our analytical experiments. Thus, the foundation layer is now warehousing, and the actual process is data mining with analytics on it. That is the essence of conducting the data analytics inside the organization, moving towards smarter decision-making practices. Now, how these things flow, as I detailed the workflow, data source, what happens in a data source layer. As the name says, in the data source layer, essentially the emphasis would be on defining what data are being generated by business processes, where they are stored or loaded, how they are managed, and further taken forward for analysis. At the first layer, the concerns of the IT experts in the organization would essentially are centered around handling this challenge. So to keep things simple, what are the different sources of data formats organizations would normally maintain is, be it a simple text file or more scalable OLTP, that is transaction databases, or much semi-structured XML or other modern web interchange formats like JSON, etc. Typically, majority of the organizations globally around the world also opine to maintain, store their data, or even process the data also using spreadsheet applications, spreadsheet files like Microsoft Excel based spreadsheet packages. Now, whatever is the variety of the data sources, one should understand where are they being generated from. So for instance, as I was briefing a minute ago, a transaction processing system that would handle customer billing at a grocery store or a supermarket would typically be a retail point of sale system that would generate data in a structured format. You can consider that as an example instance of a database. Similarly, websites, which are actually the face of businesses in the web internet driven world today, they might allow the user to navigate through the web pages, spend some time, explore the information assets on the websites, would actually be the backend interactions that would take place with XML and JSON web interchange data format. So these are all the different availability sources, and there's a very finite list in place, but apart from these data sources, there are multiple varieties of data sources depending on the type and nature of the IT infra that is being used in the organization. It can also be more complex ERP system or MIS or even cloud-based repositories also. So at the essence, data source layer need to be understood, because one who understands implementation of BI should have a thorough, clear picture of the sources of data generation and managing them before they're taken forward for integration. At the staging layer, if you see, which is the second phase in our BI framework, second staging layer is very carefully need to be performed, because proper care of ETL would actually generate the required data that we can pump and flush into our data warehouse. Typically, this is the ETL layer, otherwise, or staging layer. Essentially, the efforts here are, we need to understand some technical processes and some tools also, how we can move the various sources of data formats that can be homogenized into warehouse by moving the data to the operational data store. The staging DB is, you can consider it as a mirror image or unrefined image of data warehouse before data are moved and into the data warehouse in a cleanser format. Foundation layer, which is actually the core of business intelligence at the heart, that is BI, data warehouse construction. The objectives of building data warehouse by an organization as part of the BI activities, essentially, they would like to contain the data in homogeneous view for reporting in A2A in decision making. So you can imagine data warehouse a near equivalent of database. There is not much difference in terms of its operation between a database and warehouse, exceptionally the characteristics of containing the data. So nothing but a data warehouse is a mirror image of the database containing historical enterprise data. While databases keep updating themselves by time and space dimension, data warehouse is like a recall of all the data that were generated by the business process as a historical mirror image of the data. Because analytical experiments need to look into the past and historical experiments. That's why a statement which I say, can we learn from our past to become better in the future, is obviously a rich truth, right? That's why warehouse can be considered as a mirror image of the historical facts of the business process. But one should understand data warehouse differs from database because in data warehouse, there is no live transaction processing, only analysis of the past data facts is carried out. Now, from the access layer, this is nothing but for customization, where to deal with analytical experiments on the big container repository, which otherwise would be very difficult in practice. That's why IT specialists of BI would like to break down the data warehouse into smaller subcomponents. Typically, you can call each component as a data cube or data mart. On each of the data mart, like you can consider a data mart typically in the language of a database system, something like you generate a view out of your database table. A database relational table might contain many tuples that can be queried relationally. But if you want to have a certain view of your data, you can generate a higher level view of data upon which you can position, place your research analysis on. So the construction of data marts, implementation of online analytical processing through data mining practices is at the core of access layer. The outcome of all these activities would route to the final layer, but proper data mining framework understanding, application of selection of technology tools, all varies on the nature of and complexity of the data that we are handling with. Finally, in the framework, after all data artifacts have been understood, explored, modeled, and then it's time to offer the data to the presentation layer in much more synthesized format. That's why in the presentation layer, different information reports varying from organizational capacity, that is from a strategic executive level to the management tactical level to the operation level, different kind of information reports for knowledge synthesis are generated across. So this is how a quick understanding of business intelligence systems development and implementation practice can be taken by our participants today. Now, we have understood enough of our BI in the last 1 hour. Now it's time for us to move towards the theme of our FDP, that is data analytics. While this is a very well-known term for most of us with our experience and exposure, let me take the opportunity to introduce from the basics what is data analytics actually is for. Data analysis already is there in the world. Now why we need analytics of the data? There is one simple essence of data analytics, nothing but from implementation, usage and belief phenomenon paradigms. Data analytics was understood by practitioners, by followers, even philosophers, as it is the opportunity for the observer to look more deep into the data for the objective of deriving much more meaningful insights. Data essentially has very less meaning in its raw nature. When data properly processed and translated into information, information is more meaningful than data, because such meaningful information, when further synthesized into knowledge, and such synthesized knowledge when put into action, will lead to better business decisions and opportunities. That's why, keeping this a vision of data analytics, now let us discover, after having a technical implementation of BI, how can organizations still go further forward with analytical implementations of business intelligence and achieve operation excellence. Speaking from data point of view, the raw data, which are facts or day-to-day observations of the business, contain least valuable knowledge. That's why it's become necessity for the organizations to look into IT practices that transform data into not just a simple information report, but essentially a knowledge horizon or a knowledge management system. How can we achieve transformation of data to information to knowledge? obviously the unique solution is to understand and implement the possible analytical methods. When analytical methods are valued upon, how can they be implemented in a real-time practice with different areas of practices of the data science, be it analytics, machine learning, artificial intelligence, or big data management, whatever the area of opportunities are there under the spectrum umbrella of data science can all be understood here. Now, if you look at the organizational data management structure pyramid, at the lowest level is the pivotal data. Like all organizations can collect data in their basic form. They try to organize this data through various means and practices and translate the data into information. Now, is it sufficient enough if is that information that we generated, is it quite enough to handle our day-to-day business decision making, or should we further go ahead? While decades and millenniums ago, the process of data to information practice, which is in place, which shall be in place in the present and future, is good. But the journey of information management further is summarizing the information into knowledge through proper analysis and further synthesizing the knowledge to translate that knowledge put forward into actionable decision making is the actual goal of analytics. That's why I would recommend all our esteemed participants, you start with synthesis of data and then you move towards analysis of data, I say. Do you agree, participants, all of you? Every day, our research practices in our academic learning, industrial practices, applications, all shall start with synthesize first and then analyze next for productivity. Now, have a quick look at this picture I'm presenting for our participants. I just call it as raw data. Could anybody could just explore, or I do a naked eye observation and tell me what you find in this picture actually? Take a clear picture of it and try to share your ideas in the chat with me. What do you find, any object or some kind of entity present in the picture? I know it is very difficult because it is cluttered, unstructured and randomized. Try to discover what is there in it. Shikaji says it's a bicycle. You're right, madam. Good. Others, please also give a try, because each observer has their own vision and perception capability of understanding the raw data. Aishiji also says it's a bicycle. Pankajji says yes. Most of your answers are aligned actually. Like we see some little meaning. That's why I quoted, I said raw data has very less meaning because of its unstructured, randomized nature in the real world. When such raw data is given to us, how do we generate more meaning out of it, or how do we translate that data into most valuable information knowledge? Let us go forward. Now, the very fundamental step in data analytics is start with what we call data preparation. In this phase of data preparation, the users or the analysts behind the data try to venture most of their processing time in understanding each individual elements or pieces or components of data. Like you can consider this as a puzzle. You can scramble the pieces of puzzle and take each piece of the item and have an in-depth understanding of it, of each individual data element or entity. That phase is called data preparation. Now, after basic understanding of the data, it's now time to move forward to conduct rich visual analysis or much in-depth algorithm-based analysis to add more value to that data. When we do apply visual analytical practices behind the data, we get much more meaningful pattern which otherwise was unstructured. Finally, after the efforts, we would conclude the analytical experiment with some meaningful insight. You can see here the unscrambled, raw, unstructured data, when properly synthesized and analyzed, could generate some rich insight for us. If you apply this or mimic, replicate this logic into a real world data processing system, the journey of organizations with raw data starts with raw data procurement, raw data understanding, raw data management, and finally terminates at generation of rich business insights. Thus, the workflow, if you call how the workflow of BI analytics is implemented is with multitude of raw data sources in place, spend enough time on understanding the raw data in its essential basic format, put forward the data for the required preparation, and make the data suitable for analysis and visual, and finally generate the rich insights or the hidden data patterns that can be explored and extracted through this analytical approach. This is called the data analysis life cycle for organizations. Now imagine if this approach was not there, how are organizations managing the data processing mechanics earlier to BI? Prior to BI also, we had traditional analytics implemented, but why we today call this as data analytics and why we otherwise call business analytics is file systems were there in place, which we still contain today in our personal computers or organizational computers. We have robust database management systems that offer the capability of structured data management, query processing. Having all these tools and opportunities, why the analytical approach re-engineered itself is we have the relational database systems today as the driving backbone for data storage. Based on the line of business applications, we still used to perform ETL in our olden days. Organizations used to understand implementation of DBMS, define a schema, that is a logical structure of the database, define the operational business tables, contain the data in tuple relational format, write queries, structured query language queries, and drill down the data and still produce results. When we were living with this kind of traditional business analytics, could anybody participate and tell me the actual reason of translating the traditional ETL into a BI analytical ETL? Where is the actual drawback of this architecture, participants? See, we have a database system, either Oracle or Microsoft SQL Server or a MongoDB or no SQL based practices today. What made such practices migrate, transform themselves into analytical methodology is the question being asked. If you see the structure, what is being presented here, the defined schema, do you think the structure or the logical design of the database keeps growing by virtue of time? The more are the business processes added into the ecosystem, obviously the structure of the database needs to grow accordingly. Do you think managing such growing complex schema of the database is that easy? Even though if we manage that schema through certain practices, the challenge lies with querying the data. Typically, what time a query might take, I mean a relational query might take to query a database table of 100 transactions in real time? Not more than 10 to 20 seconds. But if the same relational query, when fired against a big data containing around 10 billions and petabytes of tuples, what could be the processing time for the query participants? Anybody? Would it be again 10 seconds or would it be quite higher? What do you say? The query processing time for enormous continuously streaming data in a backend database would obviously grow higher. That's why to optimize the query performance, irrespective of the size, volume, and variety of data, and to generate sufficient analytical results, this traditional business analytics process or the old school legacy relational querying process has been transformed into the same modified analytical querying with BI. Thus arrives the need for data analytics. Before we implement the data analytics into the real world with BI foundations, one needs to understand what are the different categories of data analytics which are there, when and how each of these components need to be understood, realized, and applied. Essentially, there are 4 different categories of analytics, starting with the first, descriptive analytics. In a fundamental form, data analytics lies at the core of descriptive. As the name says, descriptive, essentially the players of the data or the users of the data who venture their time and effort in researching on the unlocking the potential value of data must start their journey from looking in the past of the data. That's why descriptive analytics would start the emphasis on what happened with the business process in the past. For example, if you take a banking institution as a use case, a banking institution offers a variety of services to its customers. One of the most on-demand service is like a credit processing or the loan management. How can banks and financial institutions actually handle this complex business scenario? Because if the profiles of the loan applicant not properly synthesized and analyzed, that would lead to greater risk rather than an opportunity for the bank. That's why to make a critical decision around that scenario, organizations like banks and financial firms can start their journey of analytics by looking in what kind of profiles were actually they were scrutinizing for loan management or loan profiling. Such knowledge synthesis needs to be taken from the past. Such activity can be attributed to descriptive analytics. The next variety of analytics, data analytics, is diagnostic analytics. As the name says, diagnostic, this would focus on trying to understand why an outcome of the business actually took place. For instance, why a certain profile of the customer in the bank who applied for a loan has been ruled out or rejected. What parameters were taken into consideration? What analysis was carried out? How could the synthesis of knowledge derived? So besides looking what happened in the past, what made the business outcome happen in the past comes under the realms of diagnostic analysis or analytics. The third and most predominant category of data analytics, which would make the waves of data analytics go into the modern IT implementation, is predictive analytics. A question to all the participants. Do you think business organizations should prepare for the present as well as future also? What do you say, participants? Reply your answers with yes or no. The business entities or the world should prepare for the future also? Yes. In simple words, I mean to say, should organizations should have the power of forecasting? Should they prepare to get the magical forecasting with them? Obviously. That's why the analytics with prediction gives the power from BI and BA practices from what happened in the past and why it happened, what might or shall happen in the future is where organizational maturity is majorly benefited or enriched from the business intelligence framework. Then once we have the power and ability to foresee and forecast the future of business processes, we could then build up what we call the action to be carried out in the next. That is what simply call what next or what to do next comes under the realms of prescriptive analytics. So to sum it up, diagnostic and descriptive analytics can be made one category. Predictive analytics, the core and foundation of data analytics, and prescriptive, the future recommendations for the business. All these are on top of business intelligence paradigm. Thus, if one has certain confusion still between BI and BA, let me clear it for you all. There are 4 essential parameters that I would consider for a differentiation on basis of which I would like to differentiate between business intelligence framework and business analytics methodology. Today, organizations have, after understanding the value proposition and framework, are very clear that business analytics is the superset umbrella under which business intelligence is a subset actually. Because first BI arrived, on top of BI, BA deployment was done. But today BA or business or data analytics takes the upper hand, under which BI practices are implemented. Well, if you see the objective of business intelligence, so far as the discussion is going on, the prime focus of business intelligence is to collect data from various sources and then combine and present them in a format which is easy to read, interpret, or understand. While business analytics adds value on top of BI by conducting analytical experiments with only objective to derive or extract valuable and meaningful insights. While the focus of BI is limited to the present from the past historical data, while business analytics or data analytics would continue the opportunity focusing from the past to present and present to the future. That's why BI is quick and reactive. Data analytics or BA is more than reactive by becoming proactive. Now, at this point, I would like to once again ask our participants, do you wish to recommend for any organization that was living with some kind of data processing mechanism, would they now need to transform their operational structure into BI and BA practices? Yes, they should obviously venture into first acquire BI and then transform to data analytics or business analytics practices. If you look at each individual component with examples, descriptive or diagnostic, that's why I said both are now fitting into one umbrella. This would obviously tell what happened in the business. For example, a manufacturing firm is trying to keep an eye on the expenditure made for business process and the income or revenue generated on a monthly basis. So you can treat something like an monthly income statement being prepared using a spreadsheet package like Excel or any other software tool. How descriptive analytics can help the organization to keep track is over different business heads or financial heads, data related to business can be populated and opportunity can be given to the analyst or the user, end user or manager to prepare a very good report, solid report that would aid in understanding what actually is happening in the business in the past to the present. So such daily operating report in a manufacturing firm, like operating the value chain or assembling, or I mean to say the recovery management practices, trends and patterns could be understood. Then, do you think that report would be sufficient enough? Of course, report is a very basic information asset, but the complexity that lies with the report by time and space is unexplainable, because the amount of parameters that lie in the information report is unutterable. That's why translate that complex information report into much easier readable format by doing some data practices like consolidation, data visualization that would extract the summary of the complex report in much easier readable, manageable format. So this is how descriptive analytics adds more value to the core data processing and management on the BI. The second category is predictive analytics, which is actually most essential, empowering the forecasting power, focuses on what is the probability or likelihood of a business outcome in the future based on the past. That's why essentially predictive analytics would lay the emphasis on data modeling. It's not just a data exploration and visualization. Analytics of predictions would help the practitioners or data enthusiasts to move towards one step ahead, that is data modeling, with essential goal to capability to generate forecasts of the past and present data. For instance, a sales and marketing department in a business organization is generating a lot of information through every day, every month, every quarter business process data outcome. How can such data be used by the analytics team inside the department of sales and marketing so that they can generate a forecast of how likely these sales are going towards a progression, that is inclination or declining sales pattern, they would like to know in advance. Having such a vision with predictive analytics, do you think will be useful for the sales and marketing department or the enterprise as a whole? Obviously, because to keep pace with the competition, to do new product offering, product innovation and service offering, and stay ahead of the competition, or to have simply what we call competitive advantage or edge, definitely the data of the past, when correctly modeled with predictive analytics, can give a roadmap to the organizational workforces to keep track of what is the chances of the business outcome in the future. But success of predictive analytics completely relies at the hand of descriptive and diagnostic analytics. Because how we understand the occurrence of a business outcome in the past and present, essentially that knowledge insights would give us the forecasting power with greater accuracy to predict such outcome it might reproduce or reoccur again in the future. Prescriptive analytics, which is at the higher level of analytics or the topmost category in analytical implementation, would focus on what next to be carried out based on the forecasted outcome. For example, many businesses are nowadays facing one common problem of customer churn, that is retaining the customer. Be it a telecommunication industry, be it is a competitive banking and financial industry vertical, or be it healthcare service sector, or whatever is the line of business, most of these organizations have very common problem of customer satisfaction, customer enrichment, quality of the product and service are all at stake. Can analytics of data give some opportunity for those organizations to handle such critical business challenges? Or even if you see in terms of engineering and manufacturing, can we cut down the processing time, or can we optimize the supply chain processes in terms of product management, raw material management? All these kind of different verticals would like to learn from the basics of descriptive to predictive, and finally move towards what has to be planned in the future accordingly based on the observations and predictions, what we typically call a prescriptive analytics. In prescriptive, the major focus would be on business KPIs, that is key performance indicators like cost optimization, effective and efficient time management, quality process improvement, and finally customer satisfaction. All such kind of metrics or business outcomes can better be understood and handled using the application of prescriptive analytics. Now, at the juncture where we are in currently, if one would like to finally disseminate or discriminate between BI and BA, it all started with data as the driving force, while BI was trying to re-engineer the basic core legacy IT operations by adding some value added layer through data warehousing and data mining operations in order to improve productivity by managing the work efficiency or knowledge management efficiency, to align operational efficiency to meet the organizational goals. While BI could spearhead so far, business analytics adds more value on top of these implementations by further refining, re-engineering the BI to construct knowledge models with the data in place, or creating more scalable and performing business models that could otherwise help organizations to address any type of challenge related to goal management, decision-making criteria, or further innovation. That's why together, business intelligence and analytics of the business with data are now the primer or the next normal. Now, where to begin our journey in the FDP? There's a lot theme discussion around B and BA. How does a beginner would venture into these practices? Where to start with? Visual analytics, or the practices of crunching the real world data through visual analysis, is where it all starts with. as defined by the famous author Andy Kirk says that the approach towards data management is found different in different real world environments. But globally or universally accepted truth is a better and simple approach to start analytical experiments in the organizations is to start with visual or pictorial representations of the complex data, because human has the capability to perceive the environment quickly from the neural system cognition and perception capability. That's why to venture our journey into analytics, a recommended stepping stone practice would be to start with visual analytics. Now, how I differentiate visual analytics or how it correlate to implementing BI/BA, let me demonstrate. Visual analysis comes from the approach of implementing business intelligence or data analytics. So you can imagine visual analytics is the technical implementation to realize BI or BA. Simply saying, visual analytics deals with translating or transforming raw data into pictorial or graphical representations. Such combination or conglomeration of several visuals, when brought together, forms what we call a presentable information dashboard. It can be a static dashboard or more interactive dynamic dashboard. The dashboard essentially brings all the business facts in a single centralized view, thereby providing the opportunity for the observer researcher to understand better critical insights at one place. Nothing but we try to extract the patterns of the data or trends in the data through individual visual explorations and then try to combine them into a single homogenized view. If you want to conduct visual analytics using any of the popular tools in the market, from a simple Excel to a more statistical SPSS or more open source R and Python, or more visual practices like IBM Cognos, Tableau or Power BI, whatever is the brand of technology, essentially all these players would encompass or include some fundamental steps like application of statistical techniques, doing in-depth data mining, and then moving towards application of analytics. A typical question that would arrive now at this point is, are data visualization practices sufficient enough to generate rich, useful knowledge insights for an organization, or should we leverage much more? At the outset, data visualization practices are an entry point for analytics, and such a journey can be taken forward in more robust manner through other modern and advanced data analytics practices. So what is human perception and cognition is centered around data visualization is understanding, capturing, analyzing the rich complex data through our neural system of the brain to perception and cognition practices. So to understand this complex terms, let me present to you participants a very simple illustration. You are seeing some math on my screen, right? So there are two numbers which I'm trying to give to you. What shall be the outcome of this mathematical operation? Anybody? Like 34 multiplied by 72. If you see, to solve this simple problem, each one of us need to do some operation of math, that is multiplication, and generate some outcome, which is obviously time taking. If I increase the complexity of the problem by increasing the volume and variety of the number, obviously more time is required by the observer to process the data. Do you all agree? So if I multiply 34 by 72, I would go with a math and would arrive something at my outcome, which is 2448. Thus, using the legacy data management practices yield to more time consuming operation. Contrary, opposite to this, if I would present data rather than in some legacy practice as a visual practice, for example, a business is trying to discover the outcome of an operation in terms of two categories. So if you see, the paper and pencil ability where we manually try to pitch on the calculation, whereas the ability to perceive a visual through our cognitive capability thinking is quite higher than a traditional method. To understand this implementation, let me present some snapshot of an information report of sales and marketing department related to a product company. If you see the snapshot of this report, participants, this company is trying to sell some products related to furniture category, office supplies category, and technology category, where under each category there are further subdivided subcategories of each group. The numbers which you are seeing on the screen, the positive and negative values, represent the actual sales of each category and subcategory. Given this report in front of you, if I would like to ask all the participants in the evening session, could you quickly observe and figure out and tell me this company achieved maximum sale value under which category, under which subcategory? And for information, there is another parameter in the report, that is customer segment, which can be consumer, corporate customer, home office, and small business. The numbers represent the actual sales of the different category and subcategory of products. Given such huge information report in front of you, do you think is it easy to go inside the data, explore the pattern, and bring out the answer for the question asked, that is, which category witnessed the maximum sale? We can still answer this question with some time and effort in place. But imagine if such a complexity of the information report is increasing by time, the question becomes unanswered, I say. Then how to answer this insight generation? Simple thing is, you can format your data, pre-process your data, and try to present in a format which is readable. For instance, the total sales, if you can see, the certain sales figures are presented in different nomenclature for better understanding. If you carefully observe the report now I am presenting to you, still there are numbers on your screen. Some of them are highlighted in a red color or a different color, while others are presented in regular color perception. Now, going with these data processing practices, would it be easy for you to distinguish or differentiate between the positive and negative sales? What do you say, participants? Simply, this report is much better and refined one than earlier what we saw, because the negative sales of all the products, which negative sales and are nothing but losses, negative profits or losses, which tell what categories, subcategories, and which customer segment yielded the negative profits. Thus, by properly processing the data in a format which is presentable, readable, understandable, we could easily generate some quick insight from the data, which otherwise was not that easy to answer. Yes, you're right, Zohaib Hassan. It highlights only the losses here. Further, we need to add more analytical approaches to drill down our data carefully through visual practices and other analytical approaches that would allow us to discover more rich information insights. So now, moving forward, if I convert all that high number crunching game into visual practice through certain visual insight, like I present a bar graph, now you could see a typical bar graph data visualization that is adding more value to the knowledge. Now you could clearly see the projection of the bars on the visualization would tell us the fact that which category, which subcategory, and which segment of the customer could actually generate. You're right, Zohaib Hassan. Again, it is the office categories supplies under machines in corporate. See how quickly you could generate an insight, participants. I hope all others are able to understand where I'm pitching upon the essence of the discussion. Raw data, when properly explored, analyzed, visualized, could generate a value insight which could lead to robust decision making. Thus, in the future, this business could understand a pattern from the data clearly, that which category and subcategory should be sold to which customer segment prominently. But this report doesn't mean other categories need to be overridden. Yes, our efforts with analytics only are to discover the knowledge That's why the synonym of data mining, in other words, we call data mining as knowledge discovery in databases, KDD. So we are not trying to take the actual outcome and neglect the others. We would like to do multi-dimensional analysis for better outcome of the business, right? So the cycle of visual analysis is start translating or collecting data, procure the data. While raw data is highly unstructured, try to find a suitable structured mechanism. Try to explore each individual piece of data through proper data preparation and analysis. Extract the rich insights from the data. Based on the insights that were extracted, now dispose or deploy your decisions for future businesses. That's why I would like to present finally to all the benefit of all our participants, how to choose right visual element for each type of data. We all know from our experiences of the practice data, a typical question to all our participants. Essentially, if you have the experience of visualizing data in your research projects or in your teaching curriculums with your student, can any data be visualized using any visual element, or should we need to know the inside out of what fundamental data visual practices should be known in advance so that each data element can be visualized carefully through proper data visual elements? That's why this slide or this information artifact is for the benefit of participants. Essentially, as a data scientist, I would like to consider my real world data management in 4 different horizons. The first one is sometimes and most of the times in our routines day to day, we would like to take the opportunity to go for mutual comparison of data or the business outcomes of the data. That's why if I position my knowledge horizon across comparison, if you want to compare 2 or more data which are quantitative in nature, essentially, our opportunities with quantitative comparison of data would lie around 2 horizons. One is among the items and items by time frame. If you want to go for a mutual comparison of data, like sales of one financial year with sales of another financial year, or sales progression over different quarters, you can choose to pick up from among items category. Again, you can study one variable per item, univariate analysis, or you can study 2, that is bivariate analysis or multivariate analysis also. The suitable data visualizations that could represent a relationship between quantitative nature of the data with certain qualitative elements include column chart, bar chart. It can be horizontal or vertical column or bar chart. But sometimes, in fact, most of the times, data comes populated appending by date time factor. For such things, we have time related parameter also becomes part and parcel of the data. Such data can be explored and visualized using advanced data visual charts like line chart that depicts a trend over a time in data, or stacked column charts, or multitude like a combination charts with line and stacked bar. That is for comparison analysis. Also, most of the real world data is numeric in nature, participants. While data can be segmented into what we call continuous data, that is spread over a distribution, categorical data, which is non-numeric in nature, especially for the continuous attributes, numerical, we have a separate set of visual tools in our analytics, namely the distribution of data by analysis by understanding the spread or distribution through histograms, density plots, line histogram, or to study the relationship between 2 continuous variables x and y through a scatter chart visualization, or more complex visualization through a 3D area chart also. That's why one should understand how to pick up a visual scheme or visual representation for what type of data. Then so that you can position your visual analysis correctly. The third is the composition, where we need to study the inherent relationships between the data. Composition can be attributed to 2 things, that is changing by time or static in nature, where we could figure out how we could project the data in form of visuals using refined, much advanced charts like stacked column chart, stacked area chart, or if you want to represent data item in relation to the composition or proposition of the whole data, better you can go for a pie chart. That is, if you want to represent one entity in relation to the total whole value of the data business outcome, you can represent it as a pie chart or much more matured waterfall charts. Then finally, to model the relationship between the real world entities, like I said, if both are continuous in nature, where both data items that you are visualizing are numerical in nature, you can go for a scatter chart. But if you want to study the attributes relationship that have continuous, discrete or categorical, you can project them as a bubble chart. That's why this basic fundamental understanding of choosing the right visual scheme for right type of data paves the foundation for solid data analytics in our hands-on experiences. I hope this is clear for participants. Finally, in the last few minutes, I would like to present what kind of applications are in the real time for analytics. Which organizational sectoral applications are available in different industry. I would like to walk through and then go for final question and answer. If you see, there are different business processes in different industries. For example, banking, financial, insurance sectors every day are nowadays struggling from selecting suitable valid customer profiles. That's why if you take the use case of fraud detection, consider the scenario of risk management, bank BFSI, shortly the bank financial services sector with insurance lead, are all trying to apply analytical practices to handle these complex scenarios. Now, if you consider the core marketing research, sales and marketing departments, where real intelligence is needed to understand the dynamics of customer relationship management, the true appeal of analytics is felt by applying business intelligence and transforming marketing into the future phase, that is marketing intelligence, especially in production engineering or core of the manufacturing, where managing the supply to demand, that supply chain process is quite typical and influenced by time parameter. Understanding the workflow of supply chain in manufacturing or more robust engineering, analytical applications are done. Typically, the high end of applications in supply chain is where the backup recovery teams could focus on estimating the remaining useful lifetime of engineering components, or trying to discover the art of estimating a failure in the supply chain engineering structure ahead of time, what we typically call the project as predictive maintenance participants. Predictive maintenance or preventive maintenance through analytical applications in supply chain engineering, or optimization of demand supply business models for warehouses, especially for businesses that would venture into the finance departments, how to manage an expenditure versus income revenue parameters by using the past principles of data, how to prepare the roadmap for future optimization of financial investments, especially in the e-commerce sector. Revenue management completely goes with analytical applications. And there are a multitude of applications around this. So in marketing and customer intelligence, the teams would like to apply understanding the entry and exit points of the customer, measuring the customer lifetime value, CLV component, how long a customer would connect to the business, or when can a customer exit due to lack of interest or other available opportunities and choices, can be modeled using marketing mix or marketing optimization techniques. Risk management, nonetheless, with predictive analytics gaining more importance in application, certain business models like credit risk scoring, operational risk management, and trying to venture into, like if you see now, the financial institutions are more looking at our credit score or CIBIL scores for granting or rejecting loans. How these parameters evolved over a period of time. It's all by churning, synthesizing the data parameters in place. And the heights of risk management is going towards much advanced practices with machine learning based credit risk models, AI based portfolio risk designs. Supply chain, as I said, procurement of raw material to production manufacturing engineering, ability to estimate the demand needs versus supply capability, stock inventory warehouse management, all these fit into the analytical applications of supply chain research. Today, we have analytics for supply chain, basically focusing on optimization and reduction of time management from procurement to manufacturing to delivery in supply chains. Fraud detection, a value added experiment with analytics on top of risk management, is trying to classify, cluster, segment the customer profiles into chances of likely profit probability, unlikely profit probability by application of analytical experiments on data characteristics of the user profiles in different industry. Revenue management, of course, all businesses would definitely converge finally at building up and expecting the revenues. How can we keep pace of estimated forecasted revenues from our past revenue systems that we have? That's why demand forecasting, cost optimization, especially are becoming more needy for multiple business organizations. For example, a warehouse would like to ship products through cargo mechanism to different retail outlets. What are the probable methods of minimizing the transportation time and maximizing the profits through different shipping modes can all be explored under the application of analytics for revenue management. There are other minimal applications like how can we downtime the business processing time in terms of POS, point of sales, or new product innovation, new service offerings to our customers from the existing, can all be under the umbrella of data analytics applications. To sum it up all, the journey that we started, like dawn of time, technologies evaluated to the time that we are currently in. Businesses and IT should have now an alliance, I say. The congruence of these two shall be the new game changer, moving towards productivity, efficiency, and operational excellence. That's why the transformation of organizations at the core today aligned with the data practices from business intelligence approach to data analytics now will transform the organizations to become in the 21st century as data driven organizations. Those organizations that adopt, that transform, that have the ability and agility that is adapting to the changes will have a sustainable and survivable model of business development. So at the outset, participants, this is how the initial know-how session on introduction to the approach of business intelligence paradigm and moving towards more better methodical data management practices with analytics is centered around. So I would like to thank all the participants for listening to me very patiently from the last couple of hours. Now the floor is open for any questions. Shivam, allow the participants for
Yes. Yes, sir. So now, dear faculty, we are open for the Q&A. So I request everyone to please post your queries, or you can unmute yourself to ask a question. So,
if any participant has any queries on the discussion done so far, you can come up with your thought, question in the chat, or verbally you can unmute and speak. We are still muted, I think. There's a participant.
just give me a minute.
Who says still muted. Yes, you're getting your access, Zohaib Hassan.
Yeah, now faculties are able to unmute themselves.
Yeah.
Hello, Mohan sir.
Yeah, I can hear you, sir. Please go ahead. What's your query?
Actually, sir, in our daily life and all the daily works, we use Excel a lot, but we
Correct.
don't use it to its fullest potential.
Exactly.
So according to you, because you work on this data analytics and business intelligence. So
Right.
according to you, how much useful is it for data visualization and business intelligence?
Yeah,
Excel.
good question. Your good name, sir?
My name is Zohaib, sir.
Zohaib. Okay, fine. See, always the essence of understanding technology should be from application point of view. In our entire discussion and with the experiences that you have in past, While data is the problematic element to be dealt with and technology is a catalyst to be applied upon, our focus should be emphasized on, rather than venturing into the technology stack, which is ever expanding, volatile, and definitely to re-engineer. If we can picking up a selection of a tool, like Deepesh also asked which tool for data analytics, near equal question. It is sufficient if we start with one or two technology stacks. There is no compulsion that we might limit to ourselves to use Microsoft Excel, or we need to switch over now time for any other most tool. Any tool you take, X, Y, and Z, come up with some kind of features, opportunities. But rather, I would advise all our esteemed participants here on the evening, always align our thoughts in terms of research context with data as the primer component, while in the back end, secondary is what technology comes in. Today, we might explore the data with Excel, but what are the situations that demand us to move towards the ever-growing technology stack? The limitations include the capability to explore in depth, the capability to explore the inherent relations of statistics and mathematical models that otherwise lie inside. That's why there is no particular technology, Deepesh, like there is no particular predefined or benchmarked tool that we can say, yes, this is used for this kind of testing. We should make sure that our objectives of research, our availability of data assets, and the goals for which we are working on for our research, are they in line, and the selection of technology based on these objectives, are they suitable for that implementation or not? Sometimes we can complete our research problem analysis with Excel also, Mr. Zoe. Sometimes we need to discover more beyond that based on the objective of exploration and modeling. That might demand us to move towards much more higher end technology platforms. One feature is much available in other platform than the other, while there is a lack of this thing. So that's why the world of technology is growing so rapidly that it is leaving a bias or chaos, confusion to the end user. Where should I start my application part? But again, at this juncture, I would like to cut down that bias by simply stating, position your research enthusiasm on the objective data part of it, then selection of the tool accordingly be done based on the goals of it. Hope, gentlemen, you are clear with the explanation. Any other questions, participants? Yeah. Any other questions are welcome in quick time. This is a very introductory session on the know-how, but the actuals will be realized when we go into the hands-on. What about people who want to start learning? Yes, actually this FDP is not for people who already know data analytics. This is for people more of that kind to
sir, I have, pardon sir, Mohan sir, I have one query, Vishal Paranjpe here.
Yes,
sir, I want to know that as a part of data analytics, no doubt that for MIS and DSS sort of system for the top management officials, this is a very vital and a fruitful tool for nowadays. But
correct.
When we talk about the NAVE engineers who are coming into the IT platform, for them, how this particular tool can be versatile and very boom for them? Kindly, please.
Yeah. Good. Very good question, Vishalji. See, the summary of the discussions presented, the technical architecture, the high-end mechanical framework that was presented is actually pursued by end user. That is it meant for a leadership level? Is it a digital leadership that we are looking into with analytics? Answer is both yes and no. But to be a beginner, where to start our entry point journey? See, you need not do a BI or robust BA for a simple data problem. For example, if you want to assess a very simple micro problem like to understand the current sales of a business process, you can still discover the knowledge pattern by using a simple visual chart or a simple decision support system that you rightly said, or an information report retrieved from an ERP or MIS. But are we trying to restrict our knowledge synthesis there? No, our vision is to go towards much higher level. But to start from the entry point, from tool point of view, technology point of view, there are many ways, because most of the confusion, as I already said, is selection of technology. No, selection of technology, if you keep it secondary, Vishalji, the only thing is understand the problem from its core. Whether as a strategic leader you understand the problem, whether as a tactical leader or an operational level understand, all these roles in an organization are connected internally towards the goal of solving it. That's why at an operational level, as a beginner IT, to enter into the IT platform and data analytics, you can start beginning your experiments on trying to understand by exploring the data initially. You're trying to look into the, not in a much deeper predictions initially to distinguish. You can confine the roles as a data analyst or business analyst to understand the core domain of the problem. So at the basic level, the implementation of analytics confined to understanding the in-depth understanding of the business domain of the problem and trying to spend ample time of research on exploring those rich data parameters to gear the things up to go for formulation of a tactic or implementation of a future strategy is at the higher level of the vision of data analytics. You see the data pyramid that I presented, 80%, 60 to 80% of the analytical practices lie at the operational level, Mr. Vishal. That's where the capability maturity comes in. But if one doesn't spend the ample time of research, implementation or exploration at this thing, maybe a strategy could be created in much more wrong or biased way. That's why for beginners to start with, I would rather advise to focus on essentials of data exploration and data pre-processing. Initially spend more time as a beginner under the umbrella of analytics. Once you conquer these two at the initial phase, then you can venture into the other advanced practices of building models, knowledge and business models around the data. It's an experiential learning, actually. I hope, Vishalji, you are clear on this. Any other questions, participants? If any questions are there, you can raise, put it in the chat for us. Yeah, fine then. Okay. If no questions, Shivam, then finally, I would like to greet a thanks to all the participants for their wonderful participation on day one of the FDP. We'll be meeting at the same time tomorrow to move towards understanding of the implementation of data analytics BI methodology using our IBM based Cognos platform. Thank you from my side to everyone for this session.
Thank you very much, sir, for
great evening. Good night for all of you.
Yeah.
Over to you, Shivam.
Thank you.
Thank you. Signing off.
Thank you, sir.
Yeah,
Thank you very much, sir, for delivering the wonderful session. And I hope all the faculties are very clear with all the topics which sir today's covered. So
Yeah.
thank you, all the faculties, and thank you, Mohan sir. Thank you.
Thank you, everybody.
Thank you, Mohan sir. It was a great session. Thank you, sir.
Thank you, ma'am.